My name is Brendan Kohler. I'm CTO and co-founder of Sentenai, and tonight I want to talk a little bit about something that has, over the past decade, become part of my mission and my purpose. So just a little about me. I spent a decade in academic research in using real-world data from things like drones, industrial plants, and many other kinds of sensor networks to power simulations and real-time machine learning applications. And I also had an entrepreneurial journey along the way. So in 2015, I decided to take a break from my focus on IoT and really sit back and think hard. So I co-founded a venture capital fund in Boston called Hyperplane to focus on investing in other people's hard work in sensor technologies, machine learning, and everything in between. And as I talked to more and more people, I think I eventually rediscovered my purpose and passion around helping people work better with their data. And so with my co-founder, Rohit, we went off and started Sentenai. So a little bit about Sentenai. Sentenai, as a company, our mission is to help people and processes and things all work better together, mainly through sharing their data and being able to utilize their data together. So in practice, from the product standpoint, that means that we're heavily focused on helping integrate data from many sources. We use machine learning to automate some very difficult tasks around bringing data together so it can be used together. And we are an edge-first company. And what that means is there's a lot of companies that are building cloud services and who have workloads where everything gets done in the cloud, or the idea is you collect a lot of data into a cloud environment and do a lot of work. By edge-first, I mean that we exist to support both people, like data science teams, and autonomous systems, self-driving cars, and many other systems that work at the edge in helping them do their job better by using more data from a wider variety of sources than has been possible under cloud-based environments. So to talk about data and to talk about the dream of the Internet of Things, I'd like to first start by talking about artificial intelligence, because I think there are some useful lessons in the history of AI that help us look at where we are with IoT and why we're not quite there yet, why we look at the smart home or the smart factory and say it's not quite what we imagined. So one of the jokes a lot of my AI professors told when I was in college was that AI stands for almost implemented. And what that actually means is that every time we think that we've cracked something around artificial intelligence, we discover that it's just an algorithm. The magic is gone once we know how it works, and we only wind up knowing, well, that may be something that is a little piece of intelligence, but that's not actually AI. To give you the clearest example I can of this, I can talk about Alan Turing. So when he created one of the first programmable computing systems, ACE, he wrote a lot about it and how it could be compared to a human brain. And one of the things that he believed was that you could teach something like this to play chess, but it could never play well because chess requires intelligence. He believed that intelligence was made up of a number of quite difficult tasks for computers at the time, like heuristic-based search, which basically means making a judgment based on rule of thumb. Now, fast forward 50 years, and Deep Blue defeats the world's greatest chess player. And if you looked at that time on IBM's website, they actually had in an FAQ a little piece about AI. And basically what they were saying, what their researchers were saying is, no, this isn't AI at all. This is brute force. We did use heuristic search, but that's just an algorithm. The machine cannot think. And that's an interesting, it's a very interesting place to wind up 50 years later, after we had this dream that a technology would look one way, or this imitation of a human brain would be made up of these algorithms and these techniques. But in the end, once we got there, in fact, using variations of the same algorithms that Turing himself devised, we realized we're nowhere near where we need to be. So I would like to apply the same, the same lens to the Internet of Things. So the person who coined the term Internet of Things had a very interesting viewpoint, and it was that RFID and sensor technology will enable computers to observe, identify, and understand the world without the limitations of human-entered data. Now, that's very different than really what we think of as IoT today. Really what he was talking about is giving computers the ability to sense the real world. And his, in his argument in the longer term was that it would allow computers to save us from all of our waste, all of our pollution, all of the infrastructure breaking down. Now, at the same time, in 1999, Neil Gross came up with this article in Forbes that was absolutely phenomenal. And it laid out a vision for the Internet of Things. And he said that the Earth will don an electric skin, and it will monitor everything and tell, it'll basically use sensors to learn about itself, and that computers would be able to act to optimize how everything on Earth worked. And that's a very, very grand vision. So when I look at something like a connected speaker today, I think, is this actually the IoT that we've been working towards for decades? Is this the IoT that I worked on in a distributed sensor networks lab? And the funny thing is it checks all the boxes, much like Deep Blue did for AI. It's internet connected, it has an IP address, so from the internet perspective, that's the most basic thing. But it can also collaborate with other peers. If you put two of these HomePods in a room, they can create stereo audio. It also can control your home. It can answer questions. It unlocks all these new applications. So why doesn't this achieve the actual vision laid out regarding IoT? And my observation after so long working with these kinds of systems and building these kinds of systems is that it's really about the networks. It's about the networks and the data. The cloud-based model of modern IoT systems cannot possibly achieve the Internet of Things in its truest form because it's somebody else's network. When you have one of these systems collecting data from your home, from all of these sensors, and it's sending it to a service provider in the cloud, that data becomes theirs to work with, and it may technically be your data, but if you want to use it to do something outside of that cloud, you're oftentimes out of luck, and companies are racing to use this data for their own purposes rather than the kinds of activities that we envisioned in the first place. So to move IoT forward, I think it's an interesting task. So the history of data collection involves a lot regarding cost. So in the 1970s, PLC systems allowed factories to record a lot of data. And eventually we built whole multi-million-dollar database systems called historians to store all of that data on the factory floor. But ultimately, all of this data sat in silos. No one could move this data, whether it came from an ERP system, whether it came from a power plant, whether it came from other infrastructure. We couldn't actually work with this data effectively. And a lot of enterprises today are stuck with a legacy of silos, not just in the business sense, but in the sense of the data. And a lot of this is just because the data was so expensive to collect. Now that data is cheaper, so when I entered the world of RFIDs, they had just become cheap enough to start putting in logistics applications. And now sensors are so dirt cheap. There's a company in Boston that makes these incredible high-quality microphones that cost cents, ultimately. And that's so far beyond where we were even a decade ago. We can collect all of the data that we can imagine. But what we're doing with that data in practice is we're sending it into the cloud. Now, that's great from an operational perspective, especially if you're a corporation, but it's not necessarily great from the perspective of what you can do with your data, because the cloud itself is a kind of silo. Within a cloud, whether it's a cloud service like a Salesforce, or whether it's AWS or Google's cloud offerings, or another one of those generalized platforms, it's often difficult to remove that data from one context and use it with something else, either in your own computing environments or even with other cloud environments. And that, to this day, is leading to a number of interesting companies being created who just exist to be middlemen between different cloud providers like Zapier, so that you can actually get some use out of all of the data that you're generating. So that's why there's a lot of talk now about the edge. And I'm sure most of you have heard a lot of companies talk about running machine learning algorithms at the edge. But from the data perspective, I think the edge represents something vastly more important than just putting intelligence into embodied systems. What it represents is the democratization of data collection and use, because now if we have systems that truly talk to each other at the edge, they must communicate as peers. They cannot be beholden entirely to a cloud. And that gives us the power to do things with the data that are what we originally imagined. Instead of an enterprise utilizing the data Salesforce allows them to and integrating something like Predix into their production line, if they have edge systems that truly collect and communicate all of that data, they can devise their own applications with their own digital teams, with their own data science teams, and they can make more effective use of technologies like machine learning and AI. So I want to leave you with this quote by Tim Berners-Lee. He founded recently an initiative for the web of things, and it revolves around bringing back the original meaning to the Internet of Things and making it so we can utilize our data where we want to, when we want to, how we want to, because ultimately, whether that data is collected by Apple or it's collected by us, it is our data, and we should be able to use it, whether we're individuals or businesses or governments. Without that, we've lost entirely the control that we originally sought when we tried to instrument everything with all of the sensors that we spent all of this capital and time on in the first place. All right, I'm out of time, so thank you very much.
Thank you very much. Since you were kind enough to not use the presentation as a company pitch, could you actually tell us about the company in as much detail as you'd like?
Oh, yes. So I gave a brief overview, but at the very beginning, but what But what we're doing as a company is we build data infrastructure that uses machine learning to automate a lot of the tasks that are very hard with data integration. When I say that we are an edge-first company, we exist to make it possible for devices such as airplanes that collect data to communicate their data effectively with people who use that data. Data scientists in organizations who need to integrate that data with data from ERP systems, inventory data from warehouses, with logistics information. There's a lot of data out there that corporations and people need to use to be able to better leverage data, to learn from it faster, and be able to make it possible for that dream of a world where autonomous systems tell us more about what's wrong with them and how to better optimize them. That dream is what we're trying to support by providing data networks to interconnect all of these devices and then bring that data to data scientists and analysts in their own computing environments.
And specifically it's time series data. Do you want to maybe talk about what's specific about time series data?
Sure, absolutely. So all of the data I'm talking about collected from sensors, ERP systems, machines, ultimately this data represents some measurement of some variable, some value at a point in time. And that's really important because it gives us a complete history of what goes on within that kind of system. So think about a large corporation with 50 years of data related to their operations, both from the equipment they own, the people, the processes. That data all lies dormant, but through machine learning and through machine learning specifically on time series data, you can take the patterns in that data over time, the patterns in that data over its history, and learn from it more effectively. And that's what we aim to do by organizing the time series data that from all of these systems in such a way that it can be more easily combined and used together, because that's often the biggest challenge in dealing with sensor data. A single factory may have 2,000 different kinds of sensors, and that's a tall order for somebody to integrate all of that data together because it's collected at different rates, it all has different variables, different types. We automate that entire process so that when a data scientist sits down at their computer and wants to work with all of that data, they can immediately start looking for the patterns in that data, for the failure modes of the equipment, and not worry about all of the steps in between.
Very good. Do we have some questions over there?
Thanks again for your talk. My question is, do you see decentralized marketplaces or computing making this easier or adapting it faster?
Right. So I would say no. And the reason is that decentralized marketplaces for data, I mean, they're very interesting from many perspectives, but the person who gains the most from my data about my business, my equipment, and everything else like that is me. And while it's possible to say, I would like to buy the data from all the people who own equipment like me and use it like me, that's a really, really tall order. And it means that there's not probably going to be a lot of data outside the data you collect that matters to your efforts around learning from data and you know, ultimately optimizing how your business works. Because that's ultimately what it's about, is you want to improve your processes, improve your efficiency, and reduce failure. And working with other people's data can help, especially if it's, you know, environmental data like weather data. But marketplaces that are very good for things like developing and testing machine learning algorithms on golden data sets, those don't necessarily apply to the world of physical systems and physical data in the same manner as they do for, you know, trying to figure out image recognition.
One more.
Hi, I'm Michaela. I actually had the opportunity to work in your beautiful city for the last 3 years until I came back to New York in March. I played a tiny part in the Boston Self-Driving Initiative. Do you have any use cases, because you did mention it as an example as IoT to the edge? Are you working with anyone that I know in Boston in the self-driving space?
Well, that I can see. That's the so our applications. I think the government is far ahead of industry in delivering autonomous systems. So in the places where we're looking at true edge intelligence right now, where we have fully autonomous systems, we're mainly looking at government applications, and you can imagine all the drone applications and such. We expect to see what? And the weather, but we're expecting more of that in the future. But right now, the edge that we care about is actually data science teams who are working in computing environments that they control, who aren't necessarily wanting to use the kinds of machine learning services that are deployed, via AWS and Google. And so people are also data consumers, and we want to support that first. But we ultimately believe that everything will compute, and everything will be able to work better by being able to learn data that other systems nearby collect.
Yes, thanks. You had commented about, on the edge, compatibility, almost equalness of systems. And then you just mentioned a little bit about government versus private sector. How does it work? Who funds that, sort of that budget gap to get the infrastructure sort of on a pari passu basis?
So that's a really interesting question. We actually took a lot of time to learn this ourselves. So from the government perspective, there's a lot of innovation groups that are trying to move faster in the government, and they're working on advanced programs that go from everything from predictive maintenance on aging aircraft fleets to developing autonomous weapon systems, although that's kind of the worst case scenario of government in some ways. The efforts there are very much driven by actual use cases. In terms of corporations tend to have digital transformation efforts when IT stops working for business units. And those digital transformation efforts often involve shifts to data science, cloud, analytics, and other technologies that help make it easier to bridge the divide between traditional enterprise IT systems and this fully data science ready organization that can consume and learn from all the data. And so in those cases, a team in charge of digital transformation, like a chief data officer leading a digital group or a chief digital officer, those organizations usually know down to the dollar how much money is being wasted in the business, and they have ideas about how they want to solve those problems with data.
All right. Thank you, Brandon.
Thank you.